Good afternoon and welcome to this lecture of electronics. In this, we are going to study about the power supply and rectifiers, right? So the basic applications of diodes that we are going to study. This is basically the syllabus of semester 3 RDM in New Nagpur University, Nagpur. And we are starting with paper one. So paper one consists of the first unit consists of the applications of diodes, in which it is basically meant for the power supplies and also we start with the half wave, full wave, and bridge rectifier circuit. So let me share my screen. Uh, yeah. So let me share my screen. I guess my screen is visible to you all. Is it visible? So the first portion that we are going to study today is the rectifiers, right? So unit one will start with those rectifiers. Let me introduce myself. Myself, Dr. N.D. Meshram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science, Nagpur. And yeah, so these are some of the circuits that we are expecting to study today. Will try to complete one of them at least. So this is the half wave, full wave rectifier and a bridge rectifier. Why they are called as rectifiers? That is also what we can study. We will try to study in this. But let us see why these circuits are required and what is the application of diode over there. So let us begin with that. What is an rectifier? A rectifier is an electrical device that converts alternating current, which is periodically reverses direction to direct current. This is a basic definition, and in only which is in only in one direction. The process of this is called as rectification. To convert AC voltage into a DC, AC current into a DC current, that is called as the rectifier. The circuit which converts AC into DC is called as a rectifier. So just remember the simplest definition that these are the words. Sorry, these are the words which are there in the definition. So a rectifier is an electrical device or electrical circuit which converts AC into DC. That is, AC means which is going to change with respect to time, and DC means which remains constant with respect to time, right? So it is at only one level. If it is 5 volts, then it will remain at 5. Okay. But for that, we require a whole circuit that we call it as a power supply. Power supply is basically the energy source of any of the circuits, any of the devices in that way, right? So power supply is basically used in where we are not able to use the higher power supplies, like we are getting at our homes around 230 volt, 240 volt AC, right? So the appliances, the devices that we are using, electronic devices that we are using at our homes, does not require that much of power supply. It just requires say 5 volt or say 12 volt DC, right? And for that, these power supplies are required to convert this higher voltage, that is 240 volt AC, into say 12 volt DC or a 5 volt DC. That for that we require this circuit. So power supply is actually the energy source where we are going to provide for the circuits. Okay, so this is the basic block diagram of that DC power supply where we are we are connecting this to a 230 volt AC, 50 hertz frequency that comes out of the points that we are having at our homes. So we are going to put this plug in that where we are expecting that it is having a 230 volt AC and having a frequency of around 50 hertz. Now it is given to the transformer. Now this is a step down transformer. We are using this step down transformer. There are two types of transformers. We have studied this also in semester one, that the transformers are having two types. One is the step down transformer. The other one is the step up transformer, right? What it actually means, it means that whenever we want to reduce the higher voltage to a lower voltage, we are going to use step down transformer, right? Similarly, if you want to increase the voltage or current, in that case from the source voltage, in that case what we'll do, we'll use the step up transformers. So step up and step down. Step down means we are going to reduce the AC voltage, right? So here we are going to use the step down transformer where since we are applying over here 230 volt AC and 50 hertz frequency at the secondary, we are expecting a voltage around 12 volt, right? So this is a this is a step down transformer. I guess network connection is gone. Just hold for a moment. Yeah, I just connected it. Let me check whether I have done that or not. Just hold. So let me share this with you, the basic block diagram of power supply that we are using. So we were here. So after giving the transformer 230 volt AC, this is actually the step down transformer and it is going to reduce this AC voltage. We have applied 230 volt AC. Now it is being reduced to say around the 12 volt or 5 volt, right? And then we are you employing the rectifier circuit. So now we are having a rectifier circuit which is going to give you a pulsating DC. Still, it is not a pure DC. So we are having a pulses sort of thing. So here, this is the portion where we are going to use these rectifiers, right? So rectifier is a circuit which is going to convert this AC, which is changing with respect to trying from say positive half to a negative half. Now this AC is being rectified and we are having only positive pulses, right? So as you are able to see over here, we are having only pulsating DC. We call it as a pulsating DC. And when we give it to, when we apply this input, this pulsating DC to the filter circuit, will be having a pure DC like this. So conversion of this AC into a DC, again, I'm having say shutdown. So conversion of this AC into a DC, the circuit where is used is called as the the say um, the rectifier circuit, right? So we are employing filter over here. Then it is given to a voltage regulator so that we'll have a regulated sort of voltage. So this is the basic block diagram of the power supply. We call it as a DC power supply, right? So which converts a AC into a pure DC. Pure DC means it is just like this. So DC is which is at a constant level. Now here we are able to actually differentiate what is AC. So it is changing with respect to time means which is going to change from say positive to negative and it will remain changing, right? So it is called as AC. Whereas the DC is it is at a constant level and for that we require this whole circuitry to make it a DC. And basically this rectifier circuit is responsible for converting this AC into a DC. I guess you have understood this block diagram. We'll be studying in depth the power supply in the coming semesters, right? So we are having a whole unit on this power supply. So we are today we are going to study about the rectifier. So this is the rectifier circuit, and there are three types of rectifiers which I have shown over here. We call it as a half wave rectifier, in which only half of the pulse, half of the wave is being rectified. Therefore, it is called as a half wave rectifier. Then the full wave rectifier, where another again the full wave of the full wave is being rectified. Means both positive as well as negative half cycle is being rectified. So uh, that is called as the full wave rectifier, and then we are having the bridge rectifier circuit. Now here again we are having the full cycle is being rectified over there, right? But bridge rectifier circuit and full wave rectifier circuits are having two different circuits. So this is the full wave rectifier and bridge rectifier. These are three types of rectifiers that we are having: half wave rectifier, full wave rectifier, and say the bridge rectifier. Okay, so we'll study one by one. So a half wave rectifier. Today we'll try to complete this portion, that is the half wave rectifier. So half wave rectifier, in half wave rectification, either the positive or negative means one of the half of the whole cycle is being rectified, right? So either the positive half or a negative half of the AC wave is passed while the other half is blocked. So only half of the wave is rectified and therefore it is called as a half wave rectifier, because only one half of the input waveform reaches the output. It is very inefficient if used for power transfer, right? So as you are able to see, if only half of the wave is used, so another half which is being blocked is being misused, or that is being blocked. So the energy is lost over there, and that is why this half wave rectifier is supposed to be inefficient while we are using for the power transfer. So maximum power is not being transferred over there, right? So this is the half wave rectifier. Then this is basic circuit of the half wave rectifier. Again, we have applied it to a AC power supply. This is a step down transformer. Now here you are able to see that the windings of the primary is more and secondary is more. The diode where it is connected over here is like this. So anode of the diode is being connected to P1, sorry, S1, that is secondary one, and cathode of the diode is connected to the secondary two through the load resistance RD. So remember my words, what I'm saying, the connections, right? So the connections is the anode of the diode is being connected to the secondary one, whereas the cathode of the diode is being connected to S2 through the load resistance RL. Okay, and the output is taken across the load resistance. Okay, so this is the basic circuit of the half wave rectifier. Now, if you are able to see how it works, so this is the positive half that is coming over here. So it is being rectified and the current flows through the diode. Whereas during the negative half cycle, the diode does not work and it acts as an open switch. So only half of the wave is being rectified. So this is very good animation where it shows clearly how the rectifier, half wave rectifier works, right? So only half of the wave is being rectified and another half is blocked. So that is why this is called as a half wave rectifier. Okay, see, this is how it works. So during the first positive half cycle, the diode conducts, and during the negative half cycle, the diode does not conduct, means which is it blocks, right? So only half of the wave is being rectified. So this is how it is shown over there that the on during the first positive half cycle, the diode conducts because it is forward bias, and in the negative half, the diode becomes reverse bias, and as you know that the diode does not works in the reverse bias, therefore it does not conduct, right? So I guess this much is over for today. We'll continue in the next class, hopefully tomorrow, right? Thank you for joining. If you have any questions, please do ask me. Thank you for this. Have a nice time. Stay home, stay safe, take care. See you in the next class
Thank you,
tomorrow
sir.
at the same time. Bye. Good day. See you. Bye.